Okay, good morning, all of you. So today we have seen our discrete mathematics unit 4. Okay, so I am Professor Ganesh Jadhav. Want to explain this particular. So what is which is our fourth unit? Okay, so this is our fourth unit of discrete mathematics graph. Okay, so what is graph? Graph means there is way of saying that in graph is denoted as d E. Okay, so in graph consist of one is whatever the vertex and edges. So this is the vertex. Okay, this is the vertex. So you can say that this circle, these are the vertex, and these are the edges. Okay, lines are the edges. So set of vertex or nodes. Okay, these are nodes na. A, B, C, D. Okay, so these are the four nodes. So we can say that the vertex is equal to the A, B, C, D, E. Okay, vertex is equal to the A, B, C, D, E. So this is the vertex. Okay, and edges. Edges are these are the lines. Okay, one, two, three, four. Okay, so these four line we said that these are the edges. Okay, these four lines are the edges. Okay, so this is very simple. So what is graph? So graph is denoted as the j is equal to v. Okay, v means vertex and e means edge. Okay, so in which consist of the non-empty set of vertices. Okay, non-empty means whatever whenever these are the empty set, so we can say that this is the not graph. Okay, this is not graph, but here is the vertex. Okay, which are the vertex A, B, C, D. Okay, vertex which is also called as nodes. Okay, for vertex we also called as nodes. So these are the four nodes. Okay, one, two, three, four. Okay, A, B, C, D. Okay, so this is the four vertex and edges. Edges means the lines. So a is equal to e is equal to, so this is edges. Okay, so this is the set of the edges, a comma b, ac, be, and cd. Okay, ab, bc, ac, and cd. Okay, so this is the four edges. So we can say that this is the edges. So we have also seen the degree of vertex. Okay, vertex means the number of the edges from that particular node. Okay, number of edges. So a having two edges. Okay, AB and AC. Okay, AB and AC. So we say that this is the E1. Okay, this is the E1. So degree of this particular vertex, vertex A is 2. Okay, so vertex C. What is the degree of vertex C? So edges are AC, BC, and DC. Okay, so this is 3 edge. So we can say that this is the degree is equal to the 3. Okay, because three lines are come from the c. Three lines are come from the c, so we can say that this is the degree of this particular vertex. C is equal to the 3. Okay, this is the odd vertex. Okay, then D. Okay, how many number of the edges from the D? So only CD. Okay, only CD. So the degree of the D vertex is the 1. Okay, D vertex is 1. So we say that this is the even. This is the odd. Okay, this is the odd degree. Okay, so degree of the vertex. The degree of the vertex V of the graph G is denoted by the degree of v. Okay, so this is the denotation. Okay, degree of v is the number of the edges inside with the particular vertex. Okay, so this is the uh, vertex and this is the edges. Okay, edges from a is equal to the ab and ac. Okay, edges from b is equal to the ba and bc, and edges from c is equal to the ac, BC, and DC. And the last one is the edges from D is equal to the DC. Okay, so this is the graph. Graphs having only two main content. One is the vertex, another one is the edges. Okay, so whenever you see the graph you can understand easily. Then another one is the even and odd vertex. So what is even and what is odd vertex? Okay, so if the degree of vertex is even, the vertex is called as even vertex. Okay, and if the degree of vertex is the odd, so we can say that this is the odd vertex. This is even, this is even, so we can say that the degree from vertex A and B are the even degree. Why? Because there is the even number of vertex na, even number of the edges, so we can say that this is the even degree. Okay, and 3 and 1, this is the odd number, so we can say that this is the odd degree. Okay, so the degree of vertex. So what is degree? The degree of vertex is the largest vertex of the graph. From the above graph, the largest uh, degree of the graph is 3. Okay, so we can say that degree of the vertex. So what is degree of the vertex? So this is the degree of the vertex. Okay, degree of the vertex. This is degree from vertex A. Degree of vertex A is 2. Degree of vertex B is 2. Degree of vertex C is 3. And degree of vertex D is 1. Okay. And what they say, the degree of graph. So what is the degree? So largest vertex degree. Okay. Largest vertex degree. So here is, you can see that here is 2, here is 2, and this is 3. Okay, so 3 is the largest now. 3 is largest, so we can say that. So 3 is the degree of graph. Okay, C is the degree of graph. So this is the largest vertex of the graph. So we can say that the above graph, the degree of the graph is 3. Okay, get it now? So this is the simple one. The graph, the sum of all degrees, all vertices is equal to the twice number of the edges. Okay, so what they say, the sum of all degrees and all the vertices is equal to the twice number of the edges. Okay, so we can calculate it. How number of edges? 1, 2, 3, 4. Okay, twice number. Whatever the twice, 8. Okay, twice 8. And the number of the vertex. How many number? 1, 2, 3, 4. Okay, 1, 2, 3, 4. So, what they say, the sum of all degrees of all vertices is equal to the twice number of the edges. Okay, so sum of all degrees of all vertices. So we also calculate the sum of all degrees, that is 2, 2 to 4, 4, 3, 7, and 7, 1, 8. Okay, 7, 1, 8, and the number of vertex, number of edges are 1, 2, 3, 4. Now, number of edges are 4, and the sum of all vertex degree is 8. Okay, sum of all vertex degree is 8. So this is proved. Okay, this is proved. What? The handshaking lemma, the graph of sum of all the degrees of all the vertices is equal to the twice number of the edges. Okay, twice number of the edges. So this is the uh, so this is the formula you can calculate. Okay, this is the formula. Sum of degree of all the vertices is equal to the twice number of the edges. Then we see the types of the graph. Okay, so there are the different types of the graph which we learn in the following section. Okay, so the first graph is the null graph. Okay, in null graph you can see here a null graph have no edge. The null graph n0 vertex is denoted by N. Okay, so this is the null graph or N0. Null graph means the no edge. Okay, so this is particular graph and you cannot see here any edge now. You cannot see here any edge. So this is null graph. Okay, this is null graph. Then the another graph is simple graph. Okay, simple graph means a graph is called simple graph or strict graph if graph is undirected and does not contain any loop or multiple edges. Okay, so here is no any direction, no any direction. Here is direction of A to C. No any direction from A to C. So this is a simple graph or the multiple edge. So no multiple edge. So C to C, no any C to C. So this is the simple one. Okay, this is simple one. So we say that this is the simple graph. Okay, this is simple graph. Then the next type, third type of graph is, so this is second. Okay, second type. Then third type, multigraph. So what is multigraph? So if in graph multiple edges between the same set, okay, multiple edges between the same set of the vertices are allowed, it is called as multigraph. Okay, so this is, in other words, it is the graph having at least one loop or multiple edges. Okay, so here is particular graph A, B, C. Okay, in this particular graph, here is the two edges between A and B. Okay, A and B. But in simple graph, there is only the one edge. So we say that this is the multiple edges now. So we can say that this is the multi graph. Okay, if the graph multiple edges between the same set of vertices. Okay, same set of vertices. So these are the same set. Okay, AB having two edges. Okay, AB having two edges. So we can say that this is the multi graph. Then another one is directed and undirected graph. Okay, directed and undirected graph. So a graph G is equal to V. Okay, vertex and edges. Now vertex and edges is called as directed graph if the edge of the particular edges is made of the order vertex pair and the graph is called as undirected graph. Okay, the edge is made the unordered vertex of the pair. Okay, so here is the undirected graph A B C. Okay, A B C, and directed means the connection direction A to C, C to B, and B to yeah, okay, so this is the direction graph, okay, directed graph, but this is the undirected graph. Get it now? So here is any direction here? No, here is no any arrow which indicate the particular direction here. So we can say that this is the undirected graph. Okay, this is the undirected graph, and the set of vertex is A, B, C. Okay, A comma B comma C. This is the set of vertex, and the edges are AC, CB, and AB. Okay, so we can say that this is the undirected graph. Okay, undirected graph and directed graph. So this is undirected graph, and what is undirected graph? Okay, which is undirected graph. Okay, so we see here directed graph. We draw here what is directed graph. This is one node or one vertex. This is another vertex. So you give the name, it is AB and C. Okay, AB, CD, whatever. This is the particular node, okay, and this is the lines, directions, line. You see here arrow now. So this is directed graph, okay, this is directed graph here. This is directed graph. Get it now? So this is the simple. Here you can denote it here. Undirected graph. Undirected graph. And this is directed graph. Okay, get it now? This is directed graph. Then another type is the connected and disconnected graph. Okay. So what is connected? The graph is connected if path. You can see here. This is connected now. This is connected because all nodes are connect with each other. All nodes are connect with each other. So you can say here connected graph. Okay, connected graph. And another one is the disconnected graph, right? Disconnected graph. So this is the types of the graph. Okay. So connected graph. A graph is connected if two vertices of the graph are connected by the path, while the path is disconnected if at least two vertices of the graph is not connected by the path. Okay. If G is disconnected, then every maximum connected to the subgraph, it is called as the connected component of the graph G. Okay. So here is the, you can see in this particular difference between connected and disconnected graph. Okay, difference no any edge between this particular nodes na AC. So if here is any node, so this is connected graph. Okay, one node also. Okay, one node also, but here is the no any node between these two lines. So we can say that this is the disconnected graph. Okay, disconnected graph. Then another one is the regular graph. Okay, so what is regular graph? So the graph is regular if all the vertices of the graph have the same edge. Okay, have the same edge. In the regular graph, g of degree r, the degree of each vertices of g is r. Means the degree of all vertices is same. In this particular graph, we can say that this is the regular graph. Okay, so in this particular graph, you can see here degree of A is equal to 3, degree of C is equal to 3, degree of D is equal to 3, and degree of E is also equal to the 3. Okay, so this is regular graph. Okay, because what they say, the graph having same degree. Okay, the graph is regular if all the vertices of the graph have same degree. Okay, all the vertices of graph have same degree. So in the regular graph G, this is particular graph of degree is equal to the 3. So we can check here age degree also equal to 3. C having also 3, E having also 3, and D having also 3. Okay, so this is regular graph. Okay, get it now? So this is very simple. You can get it. Okay, another one is the complete graph. Okay, so what is complete graph? A graph is complete graph if every two vertices pair are joined by exactly one edge. Okay, so here is two vertices and joined by exactly one edge. Okay, so here is the connection between AC, also connection between AB. Okay, then the connection between CB and also connection between AC. Okay, so this is the connection. So the complete graph is graph with n vertices is denoted by Kn. Okay, so this is the complete graph. This is the complete graph. Then the another one is the cycle graph. Okay, another graph is the cycle graph. So what is cycle graph? A graph consists of the single cycle. It is called as the cycle graph. Okay, so you can see here in this particular graph, here is the one cycle now. Here is the one cycle. So cycle is start from A to B, B to C, and C to A. Okay, from first node to second node, second to third node, third to complete the cycle. Okay, complete the cycle. So this is the cycle graph. Okay, this is the cycle graph. So we can say that if the graph consists of the single cycle, we say that this is the cycle graph. Okay, this is the cycle graph. Then another one, another type of the graph is bipartite graph. Okay, a bipartite graph. So if the vertex set of graph G can be split into the two disjoint set. Okay, so this is two disjoint set V1 and V2. Okay, V1 and V2 in such a way that each edge in graph join a vertex in V1 to a vertex V2. Okay, and there is no edge in the G connected to the two vertices V1 and the two vertices in V2. Then the graph is called as biparative graph. Okay, this is the biparative graph. So how it is biparative graph? Because this is the two vertex. Okay, this is the two vertex, but it does not connect to the second vertex. Okay, it does not connect to the second vertex, is connect to the third vertex and the fourth vertex also, third vertex and the fourth vertex also. So this is the set. This is the two disjoint set AC and CD. Okay, AC and CD. So these are not connect with each other. AB is not connect. Okay, A is not connect with the B and D is not connect with the C. Get it now? A is not connect with B and D is not connect with the C, but it connect with the both of the another set. Okay, D is connected with the AB and A is also connected with the CB. This particular graph is also called as the biparate graph. Okay, biparate graph. So listen carefully. What is biparate graph? And the complete biparate graph. This is the complete biparate graph. The complete biparate graph is the biparate graph. So we see here, this above graph is the biparate, means this is the set na A and B. This is a two vertex set. This is also be the two vertex set, but it does not connect with each other and connect with the another set. Okay, connect with the another set. A is connected with the C and D, but it does not connect with the B. D is also connect with the A and B, but it does not connect with the C. Okay, so this is biparate graph. But in complete biparate graph, you can also see there A is connect with the AD and A is connected with the D and C, okay, but does not connected with the B, okay, does not connect with the B, and B is also be connected with the C and D, okay. This is the complete connection, okay. This is the complete connection. For another set, this is the one set now, A and B, this is one set, and C and D, this is also be the one set. So A is connected with the all vertex of another set. B is also connected with the all vertex of the another set. Okay. C is connect with the all vertex of the another set, that is set 1. Okay. And D is also connected with the another set, that is set 2 or set 1. Okay. So this is the complete biparate graph. Okay. Get it now. This is the complete biparate graph. So then we see the another important topic is the representation of the graph. Okay, representation of the graph. How to represent the particular graph. Okay, so there is the two way to represent the graph. Okay, so these are the two way to represent the graph. So first one is the adjacency matrix. Okay, adjacency matrix, and the second way is the adjacency list. So what? So this is the theoretical part, but when we actual move toward the example, you get easily. Okay, you can get easily. So this is the theoretical part. We see that what is the adjacency matrix, whatever the two dimensional array size, whatever the vertex into vertex. Okay, so this is the theoretical part. Okay, so in adjacency matrix, here is the undirected graph also. Okay, what? Undirected graph also. So what they say in adjacency matrix, they say that there is the particular matrix size is the V into V. So why it is V into V? So we have required the representation. Okay, as like as the we also see as per the relation representation with the matrix. Okay, relation matrix. So these types of the example we can represent the particular graph also. Okay, so here is, you can see here is the how many number of the vertex, 1 2 3 4. Okay, here is the 4 number of the vertex, and having the edges. Okay, and having the edges, and we have required the adjacency matrix. Okay, adjacency matrix of the undirected graph. Okay, undirected graph. Here you can see here connection of AA. So here is how many number of the vertex, 1 2 3 4. So right here ABCD all vertex. Okay, write all the vertex. Then ABCD, write all the vertex. Okay, write all the vertex. So here is any connection between A and A. So no any connection. So you can write here 0. Okay, then connection between AB, A to B. Yes, here is the connection between AB. So you can write 1 here. Okay, you can write 1 here. Then any connection between AC. Yes, there is one connection between AC. So right here, or there is any connection between AD. So no any connection between AD. So you write 0 here. Okay, you can write 0 here. So B. So any connection with A. Yes, here is B having one connection of A. So write 1. So any connection with the B. So here is no any connection between itself now. No any connection between itself. So you can write here 0. Then so B having any connection of C. Yes, here is one connection of the C. So simply write here is the 1. And then B having any connection with the D. No, B having no any connection between D. So write 0. Okay. For C also. For C, go to your C node. Okay, go to your C node. So any connection between AC, yes, there is one connection between AC, so write 1. So any connection between CB, so yes, there is connection between CB, so you can write here 1. Any connection with C, no any connection with itself, so write 0. Okay, so write 0. So and the any connection between D? Yes, one connection between D. So you can write here 1 also. Okay, you can write here 1. For D also, go to your D and see here any connection between VA? No any connection. So you can write here 0. Any connection with B? No any connection with B. So you can write here 0. Connection with C? Yes. Here is connection between C, or you can write here 1. And connection with itself? No any connection with itself. So you can write here simply 0 here. So here is 1, 2, 3, 4, 5, 6, 7, 8. Okay, here is 8 time, and here is connection number of edge 1, 2, 3, 4. So twice number of the edges. Okay, twice number of the edges. So this is the adjacency matrix. Okay, get it now? So this is very simple. You can easily understand it. Okay, you can easily understand it. Then the another one, okay, another type of the representation of the graph, that is adjacency list. Okay, so what is adjacency list? So in adjacency list, an array AV of linked list is used to represent the graph G with the V number of the vertices. Okay, so how number of the vertices are connect to that particular vertex. Okay, to that particular vertex. So see here A, B, C. Okay, so here is you can write all the vertex A, B, C, D. Okay, you can write all the vertex A, B, C, D. Okay, and what they say here is connection between A, B, C, D. First one is A now. So A, B and B, C. Here is the edges between A, B and A, C. So simply directed A to B and B to C. Okay, this is the list now. This is not direction of the graph. This is not direction of the graph. This is the only list. Okay, so A having A having edge between B and A having edge between C also. Then B having edge between A and B having edge between C also. Okay, you can see here B having A and B having C. So simply you write A and C. Okay, A and C. Then the third node. C having edge A, B and D also. Okay, A, B and D also. So simply write here is you can see C having A, B and D. Okay, A, B and D. So you can direct it to A, B and D also, and D having only one edge. So you can write here D here. Okay, you can write here D here. Then another what? Another type, that is the isomorphism of the graph. Okay, so what is isomorphism graph? So if the two graphs, there is the two graphs G and H contain the same number of the vertices are connected in the same way. So what we say, if the two graphs, there is one graph is G, another graph is H. Okay, here is two graph. One graph is G, another graph is H. So what they say that uh, same number of the vertices connected in the same way. They are called as the isomorphic graph. Okay, so Here you can say that age, the set of cardinalities are different and degree of the sequence are the also be the difference. Okay, so here you can say that A is connected. Here is the three graphs. Okay, here is the three graphs. So they say that these graphs are isomorphic. Okay, so what is isomorphic? So how it is isomorphic? So A is connected with the C, A is connected with the D. So here you can also see that A is connected with the C, A is connected with the D. Here is also A is connected with the C and A is connected with the D. So number of the vertex is also be the same. Number of the vertex is also be the same and connection is also be the same. Okay, connection is also be the same. Here is we check the C's connection. Okay, C is connected with the A, C is connected with the B and C is connected with the C. Here you can also see C connected with the A, C connected with the D and C connected with the B also. Okay, and here is C is also connected with the A, C is also connected with the D and C is also connected with the B. Okay, get it now? So this is very easy. And the last one is the D. D is connected with the C. D is connected with the A. D is connected with the B. Here you can also see here. A is connected with the B. So same connection here. Okay. Degree of D is 3. Here degree of D is 3. And here is also be the degree of D is 3. Okay. So here is those particular graphs are isomorphic graph. Okay, so what is this particular graph is isomorphic graph. Then we move toward the next. What? This is the example. So what they say that the following graph is isomorphic or not. Okay, so this is the example and they say this is particular graph is isomorphic or not. Okay, so what they say here is the connection. Here is the connection between. So no, left hand graph having 5 edges. Okay, 1, 2, 3, 4, and 5. And right hand graph having 6 edges. 1, 2, 3, 4, 5, 6. Okay, this type of question will also ask in university examination also. Okay, this is particular graph is isomorphic or not. Okay, isomorphic or not. So what they say, you can count the particular edges, these are particular same or not. Okay, but here is edges, you can count 1, 2, 3, 4, 5. Here is 1, 2, 3, 4, 5. Here is 1, 2, 3, 4, and 5. Okay, so in the above graph you can see here all the edges are the same. So in example 1, we can say that this is the isomorphic graph. But in this particular example 2, here is 1, 2, 3, 4, 5 edges. Now here is the 5 edges. But in this particular graph, 1, 2, 3, 4, 5, and 6 edge. Okay, so this is age equal ages. So no, here is no inequality in the ages. So we can say that this is not isomorphic graph. Okay, this is not isomorphic graph. So here they gives you the particular example if the two graphs are the isomorphic. Okay, so here is isomorphic or not. So number of the vertices. Okay, so this is the all the condition. Okay, this is all the condition and we see that there is number of the vertex 1, 2, 3, 4, 5. So here is 1, 2, 3, 4, 5. Okay, then what they say, then the vertex. Okay, number of the edges, how many number of the edges, 1, 2, 3. Here is 1, 2, 3, 4, and 5. Here is edges 1, 2, 3, 4, and 5. Get it now? Edges are also be the same. Then the degree of vertices. Degree of vertices, here is the 2 degree. 1, 2. Okay, so this is connection now. V1 having 2 degree because here is 1, here is 1. V3 also be 2 degree, here is 1, here is 1. V5 also having 2 degree, here is 1, here is 1. And V2 and V4 also be the 2 degree. So, in this particular graph also v1 also be the 2 degree 1 2 v2 also do 2 degree 1 2 v3 1 2 v4 this is 1 this is 2 and v5 this is 1 this is 5 and then the connectless each is fully connected. Okay, fully connected. Okay, so this is fully connected, both the connection is the fully and the pair connected vertices is all the correspond to each other. So we can say that number of parallel edge are the zero and everything is equal, so this graph are the isomorphic graph. Okay, get it now? Why this is also isomorphic graph? Because number of vertices are also same, number of the edges is also equal to the same, degrees of all vertices are equal to the same. This is fully connected and the number of the connected components both are the one and the pairs of the connected are all the correspond to each other. Okay, so here is v1 is connected with v4 and v3. Here is v1 is connected with the v4 and v3. Here v2 is connected with the v4 and v5. Here is v2 is connected with the v4 and v5. Then v3 is connected with the v1 and v5. V3 is connected with the V1 and V5. V4 is connected with the V1 and V2. So V4 is connected V1 and V4 and V5 is connected with the V3 and V2. Okay, so this is the connection. V2 is whatever V5 is connected with 3 and V2. So this is the connection. Pair of connected vertices is all the correspond with each other. Okay, so this is the graph of isometric. Then the another one, what they say connectivity. So what is connectivity? The graph is said to be connected. Okay, wow, when the graph is connected, if the path between every pair of vertex from every vertex to any other vertex. Okay, it should be some path of the traverse. It is also called as connectivity of the graph. A graph with the multiple disconnected vertices and edge is said to be disconnected. So this is the connectivity, means only the connection between the two vertex. Okay, connection between the two vertex. So in first example, what they say, in the following example it is possible to travel from one vertex to any other vertex. Okay, for example, one can be traversed from a to vertex e. Okay, yes, using the PBE path. So this is the path. A is travel from A to E. Okay, A to E. So this is the example of the connectivity. Then the another one is the what cut vertex. Okay, cut vertex. So in a graph, A vertex J is called as a cut vertex of G dash. Okay, so why this is called as a G dash? Because whenever delete V from G, it result in the disconnected graph. Okay, so there is the only one edge. Okay, only one edge between C and E. Okay, only one edge between C and V. So this is vertices. E and C are the cut vertices. Okay, we also say that this is the cut vertices. So whenever we cut this line, we can say that this is the cut graph. Okay, cut graph means that we can divide it this graph into the two part. Okay, this graph into the two part. So this is cut vertices. Okay, this is cut vertices. Then another one. Okay, then another one. So what they say in the following graph, vertices E and C are the cut vertices. Okay, this is called as the cut vertex. By removing A and C, graph will be become a disconnected graph. Okay, disconnected graph. So this is the cut bridge. Okay, this is the cut bridge. Which is cut bridge? C. Okay, this is the cut bridge. If the removing edge in the graph result in the two or more graph, then we can say that this is the cut edge. Okay, so we can also say that this is the bridge also. Okay, cut edge or the bridge also. So this is the example. Okay, then the another one is the cut set of the graph. Okay, cut set of the graph. So what is cut set of the graph? So this is, let V is connected graph. A is the subset of the E. Okay, A is the subset of E. E is called as the cut set of the G is the deletion all edges of the A, and G makes the G disconnect. Means the deleting of the edges. Okay, deleting of the edges from the graph. Okay, so this is theoretical part. Whenever we see in the example, you can get easily. Okay, you can get easily what is cut set of the graph. Okay, what is cut set of the graph? So this is we took the example of the graph cut set E1 is equal to the E1, E3, E5 and E8. Okay, E1, E3, E5 and E8. Okay, so this is after removing the E1 from graph, we would be appear as follow. Okay, so this is the removing. Here is the edges now. So this is E5 and E3. You can remove it. So this is the cut set. Okay, this is the cut set of the graph. So you have to cut this graph into the two part. Okay, into the two part. So you have to require to delete these edges. Okay, these edges. So you can get this one is the one graph and this one is the another graph. Okay, so which are the edges you have to require to remove it? So E3 is also required, E5 is also required, E8 is also required, and one is also be the equal. So this particular set is called as the what? Cut set. Okay, this is called as the cut set. So this is the example of the cut set. I think you can get it easily. Okay, you can get it easily. So similarity, there is other cut set. It also be okay. So there is the number of the cut sets also. Okay, there is number of the cut set also. If you have to cut this particular E3, E6 and E2, then you can get the another cut cell also E3, E6 and E4 and E9. So whenever you cut the E9, okay, you cut the E9, so you can get the one simple short graph. Okay, so this is the smallest cut of the graph also. Then another one is the edge connectivity. Okay, so what is edge connectivity? Let G be the connected graph. Okay, and the minimum number of the edges whose removal make G the disconnected graph. It is called as the edge connectivity. So what is edge connectivity? Minimum number of the edges whose removed to make the G disconnected graph. Okay, so in the other word, number of edges is the smallest cut. So here is the, you can see this graph and you can whenever cut this, so this is the smallest number na E9. This is where how many number of the collection connection here. Okay, so what I am saying, so this is minimum na. So here is how many number of age how to require to erase it? 1, 2, 3, 4. So this is 4. Say cut set is the 4 na, but we have required the minimum number of the ages. This is how many number of the ages for this particular cut set? 1, 2, 3. So this is the 3 ages. So we can say that if the graph has cut age, phi g is the lambda g is 1, then it is called as age connectivity of the g. Okay, age connectivity of the g. So they gives you example here. Okay, example here. So where is the, here is the four way to disconnect the graph by removing two edge. Okay, so here they can say that the edge connectivity. Okay, so here is you can remove here. Okay, you can remove this one, right? Or you can remove this one, you can remove this one also. Okay, so this is you can remove four way to disconnect the graph with the removing two edge. Okay, so this is four way or the number of way also. Okay, so here you can remove this, you can remove this. Okay, so this is the remove this edge also. So this is the removing of the edges. Okay, removing of the edges also. Then the vertex connectivity. Okay, vertex connectivity. So what they say in this particular graph, what they say, whenever you have to remove this particular cut, that time you can say that this is the separate graph. Okay, this is the two graph. So it is, you can also say that this is the cut edge also. Okay, cut edge or bridge also. Okay, so if g be the connected graph, the minimum number of the vertex is removed g, either the disconnect or the reduce the travel rough is called as vertex connect. So this is the vertex connectivity we have required to set the another vertex also. Okay, I and j. Okay, here is I and j. So they require to connect this particular vertex, because here is only one edge na. Here is only one edge. So they, if G has cut vertex, okay, Kg. Okay, Kg is equal to 1. Okay, so this is a 1 now. So notation of any connected graph G2 to the is less than or equal to the gamma G or the delta G. Okay, so vertex connectivity is the edge connectivity of the minimum number of the lines. Okay, here is they also be the said the ages. Okay, they also said the ages. So the kg having 3. Okay, this is the 3, this is 3, this is 3, this is 3, 3, 3. So you can say that what is 3 to 1. Okay, so 3 edges and 1 vertex. Okay, 3 edges and 1 vertex. So whenever to deleting the d and e and b and h. Okay, so where is b and h? So we can disconnect g1, not b and h, but d, e and eg. Okay, so you can get the another two number of the graphs here. Okay, two numbers of the graph. So here is kg is equal to the 2 also. Okay, kg is equal to the 2 also. So this is the disconnectivity or the connectivity of the graph. Okay, so we are stopped here. We see the remaining part at the next lecture or the next part also. Thank you.